This is lesson 7.1 of accelerated geometry, in which we are going to discover the definition of similar polygons. If you recall, we have talked about congruent figures a lot in this class so far. Those are figures that have the exact same size and the exact same shape. So that is just a definition that's not real exact. If I want to do an exact definition, it would be congruent figures are two figures that have corresponding angles that are equal and corresponding sides that are also equal. So we also have a definition for similar figures that is not precise either. These are examples of similar figures here and here. They are figures that have the same shape, you can see that, but not necessarily the same size. But this is, again, not a precise definition. And so in class today, we would do an investigation on page 374, investigation number 1. And when we are done with the investigation, we should be able to complete this precise definition. Corresponding polygons are polygons whose corresponding blank are blank and whose corresponding blank are blank. Okay, so I am going to do that investigation using Sketchpad. So these are set up as similar triangles. So what I'm going to do first is I'm going to measure this angle here, and it is 56.0 degrees. Then I'm going to measure the corresponding angle in its similar triangle, and it is 56 degrees. Then I'll measure this angle C. Angle C is 32.8 degrees, and then I will measure its corresponding angle C prime. It seems like these corresponding angles are equal, so let's see if that's true for this angle B here up above. The measure of that angle is 91.2, and the measure of its corresponding angle is also 91.2. Now, if I adjust the triangle, see how the corresponding angles are still equal. These two are equal. Angle A and A prime are equal. Angle C and C prime are equal. So it seems that the first part of that definition that we need says that corresponding blank are blank. I think we could say corresponding angles are equal. Now I'm going to hide all those measurements. And the next thing I'm going to do is measure sides. So I'm going to measure this side, that length, and I'll measure its corresponding length. And then I'm going to take those two, and I'm going to find out what the ratio would be of their sides. So if I go to my calculator, let's do the top one, the first triangle on the left, divided by that corresponding side on the triangle on the right that is similar to it. So when I divide it, I get 1.69. Okay, then let's look at side AC. I'm going to measure that length, and then I'm going to measure the corresponding side. And then I will again take those two and find out what the ratio of their sides would be. So I go to my calculator and I say the left side divided by the right side. And that is also 1.69. So it seems that the ratio of the sides are also always the same. So let's check out the last one. So this is side BC. I'll measure that. I will measure its corresponding side in the similar triangle. And then I will take my calculator and I will say the left side divided by the right triangle side, and no surprise, I get 1.69. So now the corresponding angles were equal and the corresponding sides always divide it to be the same number. What we say in math for that is that the corresponding sides were proportional. I guess I could also just move this around so that we can see again that the 1.69 there is going to stay. So these ratios always stay the same. So I come back now. If I want to fill in this definition, it would be similar polygons are polygons whose corresponding angles are equal and whose corresponding sides are proportional. And here is a sketch that you could copy also onto your conjecture list if you are keeping track of this. This is not a conjecture, it's just a definition, but if you wanted to just put that on there on the side or something, you could do that. Okay, that is the lesson for today, 7.1.